This video is about partial fraction decomposition. I'm going to do two examples. The first example, the denominator came to us factored. That's the first step when you're doing this operation, when you're doing partial fractions, is to factor the denominator. So in the first example, it's already factored, so we know we need to rewrite this into something over our factors. When I see here I have a repeated factor, I have something squared, it's being repeated 2 times. That means I'm going to have to write down x minus 3 2 times. The first time it will look like this, x minus 3 to the first power, and I'll go ahead and write the 1 for emphasis, plus something over x minus 3 to the second power. And then we need to get this other factor in here, x plus 1, which only occurs once, so we only write it once. Okay, so that's what our base looks like. Now we have to decide what goes in the numerator. You base your decision on what goes on the numerator by the degree of the denominator. So for instance, this fraction, the highest degree in the denominator is a x to the 1, or a first power. 1 less than that would be x to the 0, or just a constant. So a is going to stand for some number, just a constant that goes in the numerator. The next one is x minus 3 squared. If we multiplied this out, we'd get x squared minus 6x plus 9, which would be something to the second degree. But when you're doing partial fraction decomposition, you only concentrate on what's inside the parentheses. So what is inside the parentheses here is simply x minus 3 to the first power. And so we go off of that. We want something less than the first power. 1 degree less than that would be to the 0 power. So we again get just a constant, b, some number b. The third fraction, the highest degree is 1. 1 less than 1 is 0. So this is going to call for another constant, c. So this is the setup, and once you have that, you multiply both sides by the lowest common denominator, which is always going to be this denominator right here. So I'm just going to multiply both sides of this equation by x minus 3 squared times x plus 1. X minus 3 squared times x plus 1. This will distribute to each term, so I'm going to write it down 2 more times so I can see what happens when I cancel things out. Let's see, that's a x plus 1 plus 1. X minus 3 squared times x plus 1. So all we've done so far is set up our fractions, and now we're going to multiply both sides by the denominator. On the left-hand side of the equation, these are over 1. So when I multiply 9x squared minus 29x minus 6 over x minus 3 squared times x plus 1 times x minus 3 squared times x plus 1 over 1, x minus 3 squareds cancel, x plus 1 cancels. So what I'm left with on the left-hand side of this equation is simply 9x squared minus 29x minus 6. Now I'm going to go through and see what happens when I cancel each one of these. When I multiply a over x minus 3 times the denominator, 1 of the x minus 3's cancels. So I'm left with just x minus 3 instead of x minus 3 squared. So I have a times x minus 3 times x plus 1 plus, when I multiply b over x minus 3 squared, the x minus 3 squareds cancel. I'm left with b times x plus 1. When I get over here to the last fraction, I have c over x plus 1 times this denominator. The x plus 1's will cancel, and I'm left with c times x minus 3 squared. Now I need to work on the right-hand side. We still have 9x squared minus 29x minus 6 on the left. I'm going to multiply these two factors together. This becomes x squared minus 3x plus 1x is minus 2x. Minus 3 times 1 is minus 3. I can distribute the b as is. This is going to be bx plus b. And then I need to square x minus 3. So x minus 3 times x minus 3 turns into x squared minus 6x plus 9 when you multiply that out. Now I'm going to distribute the A. The B has already been distributed. I'm going to distribute the C. So I get 9x squared minus 29x minus 6 is equal to ax squared minus 2ax minus 3a plus bx plus b plus cx squared minus 6, oops, that's a c, minus 6c x plus 9c. All right, now I want to collect like terms, so I'm going to get all the x squared terms together and also factor at the same time. So it looks like this. I'm going to collect ax squared and cx squared together, but I'm also going to factor out the x squared. So I have a plus c right there. Ax squared plus cx squared. Now I want to look for the x terms. Here is just an x term. Here is another x term. Here is another x term. So I'm also going to factor out the x while I do this. This will be minus 2a plus b minus 6c. And then all that's left is to collect the constant terms. Constant terms are simply numbers that don't have an x associated with them. So my constant value will be negative 3a plus b plus 9c. And so that's what I have right now. All right, on the left-hand side we have 9x squared minus 29x minus 6. The last thing to do is to equate coefficients. So I'm going to set up 3 equations. It's going to look like this. A plus c is going to be set equal to the 9 because those are the coefficients in front of the x squared terms. A plus c equals to 9. The next one is negative 29 is equal to negative 2a plus b minus 6c. And then the third equation I can set up is this negative 6 is equal to negative 3a plus b plus 9c. All right, so I set up the constant equal to the constant, the x term, negative 29, equals to the x term, and the x squared term equals to the x squared term. So I have these 3 equations to solve. So over here, I'm going to be working on solving these 3 equations. So what I need to do is get rid of a variable. So I want to turn this into a 2-variable equation. Right here I have an equation with just an a and a c in it. If I could get another equation that just had an a and a c in it, that would be great. So I need to eliminate a b. I'm going to look at this equation that has a b and this equation that has a b and use elimination method to get rid of a b. I choose to multiply this equation down here by a negative 1 so that I could add it to this one. If I multiply this by a negative 1, this positive b will turn into a negative b. And then if I add it to this, it will sum to 0. So this is my choice. I'm going to multiply both sides of this equation by a negative 1. So this becomes positive 6 equals positive 3a minus b 9 plus, I'm sorry, that's why I knew I needed an eraser, plus 3a minus b minus 9c. So now I'm going to add this to this equation up here. So it's going to become 6 equals to 3a minus b minus 9c. Let's add these together. Negative 29 plus 6 is negative 23. Negative 2a plus 3a is 1a. b minus b is 0. Negative 6 plus negative 9 is negative 15c. Now that's helpful because now I have an equation with an a and a c in it and another equation with an a and a c in it, and I'm going to eliminate another variable. Now I choose to eliminate a. What I'm going to do is multiply this equation right here by a negative 1 and add it to this equation right here. That will get rid of my a's. Negative 1 on this side, negative 1 on this side looks like this. Positive 23 is equal to negative a plus 15c. I'm going to write this equation right underneath it and add it. I'm going to put the 9 on the left with the 23, and I'm going to write A plus C right here. When we add these together, we're going to get 16C plus 0A equals to 32. Is that right? 29, 30, 1 through 2. Okay. Now I get this. I'm finally going to get to solve for a variable. I'm going to solve for C. Divide both sides by 16, and I'm going to find out that C is equal to 2. So once I've obtained a number, I use substitution. I plug it into another equation to find out another variable. For instance, this C equals to 2, I'm going to use this and substitute 2 in for C in this equation. A plus 2 equals to 9. I'll subtract 2 from both sides and discover that A is equal to 7. Now I know what A is, now I know what C is, and so I can use that information and plug it into any equation that I see to solve for B. What I'm going to do is plug it into this equation right here. Here's one. This looks not too bad. This is 6 is equal to 3 times A, but instead of A, I'm going to substitute in 7. Minus B minus 9 times C, and C is equal to 2. 6 equals 21 minus B minus 18. I'm going to collect like terms. 21 minus 18 is a 3. 6 is equal to 3 minus B. I'm going to subtract 3 from both sides and find out that 3 is equal to negative B. Is that right? Let's see. 3. So B is equal to negative 3 when I divide both sides by negative 1. So now I have all 3 of my variables that I needed. I won't have time for this problem in this video, so I'm just marking that out. Here's my final answer. 9x squared minus 29x minus 6 over x minus 3 squared times x plus 1 is equal to A, which is 7, over x minus 3 plus B, which is negative 3, over x minus 3 squared plus C, which is 2, over x minus 1. Now I want just for a second to discuss this plus negative 3. You could have written this term right here. Here's an alternate way to have written this term as minus 3 over x minus 3 squared. That would be the same thing. So if you chose to write your final answer like this, without these squiggly lines that I just put on there, whoops, x minus 3, that would be just fine as well.